Hello friends, today we will discuss about introduction on OPAMP IC 741. It is coming under linear integrated circuits. So first, what do you mean by integrated circuits? It is the combination of an interconnection of active and passive components on single silicon chip. This is called as integrated circuit. Linear means analog response. The output is proportional to input signal. The output depends on the variation of input, that is called as linear integrated circuits. So in this video we will discuss about the basics of OPAMP IC 741. So the objectives: to describe the characteristics of operational amplifier, that is, what is an operational amplifier, what are the different characteristics under AC response as well as DC behavior. The second objective is to design OPAMP circuits for a variety of engineering applications. So different applications of OPAMP IC 741. It is coming under linear as well as non-linear applications. The third objective is to outline the working principle of analog to digital converters and digital to analog converters. To analyze the functions and applications of analog multiplier and PLL, it is coming in unit 4. So here we will discuss about phase lock loop and its applications, multiplier ICs, all the things. The last unit has objective to summarize the concepts of waveform generators and voltage regulators, and different waveform generators, different function generators, and the regulation of voltage. All the things we will discuss in unit 5. Right. So can you please guess what is the picture related to? Yes. And this is the first IC, first integrated circuit was invented by Jack Kilby, is the scientist, and from Texas Instruments, the industries. Okay, so first IC invented by Jack Kilby, and this place is Texas Instruments. And this is the cycle of chip making process. The chip is nothing but ICs. It is made on using silicon wafer. Silicon is the pure form of sand. Okay, this is silicon ingots or silicon cylinders, and these are polished wafers on which we are going to fabricate lot of integrated circuits. And there are the process, photolithography process, pattern silicon wafers, cutting individual chips, many things are there in between. And these are the major transformations and process of integrated circuits from silicon. What are advantages of integrated circuits? The first point is ICs are extremely small physical size. Okay, so we can comprise lot of transistors, lakhs of transistors in a small size, and very small weight. So weight of the IC is very small, and complex of electronic equipments can be employed in many applications where weight and space are critical, such as in aircraft or space vehicles. So this kind of ICs are used, and cost is reduced. It's a major advantage of ICs. And extremely reliable. Okay, here we don't have any soldering between the components, no soldering connections, so it is more reliable. Increased response time and speed. Since various components of an IC are located close to each other in or on a silicon wafer, the time delay of signal is reduced, so speed is increased. Low power consumption, because of the size is very small, it consumes very less power. And easy replacements. ICs are hardly ever repaired because in case of failure, it is more economical to replace them than to repair them, right? Okay, so what are the drawbacks of integrated circuits? Coils or inductors cannot be fabricated. It's made on using wires, right? So it is not possible to fabricate. ICs function at fairly low voltages. So most of the ICs, almost, it will work with very low voltage. So it can handle only limited amount of power. And they are quite delicate and cannot withstand rough handling or excessive heat. So these are the drawbacks of integrated circuits. Right, now we will discuss the basics of OPAMP, operational amplifier. Why this is called as operational amplifier? It is an amplifier that is best for DC as well as AC. It is performing lot of arithmetic operations. We can add the signal, subtract the signal, integrator, differentiator, log, anti-log. So these kind of multiplier, divider, these kind of arithmetic operation can be possible with the help of operational amplifier. So these are the basics of op-amp. This is the schematic symbol of operational amplifier. There are two input terminals. One is inverting terminal and non-inverting terminal. These two terminals are actual inputs of differential amplifier which is placed inside operational amplifier. And we have output pin and we have power pins. There are two power supplies required. One is plus VCC and another is minus VEE. These two power supplies are the power requirement for differential amplifier. It is a basic unit inside the operational amplifier. And this is the IC diagram and this is the top view of pin details. The first pin, so this is the 8-pin IC. The first pin is starting from the reference point is offset null pins. Second pin inverting input, third non-inverting input, fourth minus VEE, fifth pin offset null, sixth output pin, seventh pin is positive voltage, eighth pin is not, it's a void pin, not connected. Okay. And first pin and fifth pin, these two are the pin of offset null pins. It is to reduce the offset voltages. So we are going to connect one potentiometer across pin number 1 and 5 to minimize offset voltage. So offset voltage presents inside the operational amplifier due to imbalances of the components present inside, even there is no input is given. Okay. If no input is given, the op-amp should show the output is equal to 0. But due to imbalances of internal circuit, it is never going to be 0. And there will be some significant and finite amount of offset voltage always will present. That should be minimized before starting operating the operational amplifier any function. Okay. Right. What are the ideal op-amp characteristics? It has infinite voltage gain. That is input, the voltage gain will be very high and infinite input resistance. So source loading can be minimized, zero output resistance to maximize the load current, infinite bandwidth. So ideal characteristics, the bandwidth will be very high for entire range of frequency, zero noise, zero power supply rejection ratio, and common mode rejection ratio is infinite. So these are the ideal op-amp characteristics. So basic op-amp is very high gain differential amplifier with a high input impedance of few mega ohms and output impedance of 100 or less than 100 ohms. Okay, and it has always two input terminals. One is inverting terminal which inverts the input signal and it will amplify the signal. A non-inverting terminal which does not invert any input signal and it will give the output after amplification, right? The op-amp gain is very high and they can be connected open loop or closed loop. Open loop refers to a configuration where there is no feedback from output back to the input and it can exceed 10,000 and above the gain value, and if the gain is controllable then this is achieved by closed loop configurations. So the gain will be controlled and with the help of a feedback network, and negative feedback reduces the gain and improves many characteristics of operational amplifier. And what is virtual ground? Virtual ground is nothing but, see here, this is a terminal, input terminal, inverting terminal, this is non-inverting terminal. Non-inverting terminal is connected to ground, so potential drop on non-inverting is 0. So according to virtual ground, even though there is no physical contact between inverting to non-inverting, the drop present at non-inverting is equivalent to inverting terminal. This is by virtual ground concept. So potential drop at inverting terminal and non-inverting terminals are equal. And this is offset null. See here, this voltmeter shows 0 voltage. That means 0 volt input is provided to inverting and non-inverting terminal. Then it has to show always 0 outputs. It is offset null. This is the voltage required to nullify the offset voltage present inside. See here, pin number 1 and 5, one potentiometer is connected with 10 kilo ohms. Okay, so with the help of this potentiometer, by adjusting this, it is going to nullify the offset voltage if there is any, due to imbalances of internal circuit. When it happens, if there is no input is given. So if no input is given, the op-amp output should show always 0 voltage. Otherwise, we are going to connect this arrangement to make nullifying this offset voltage. This is called as offset null. And voltage follower. So voltage follows nothing but the output, the op-amp output always follows the input voltage. Okay, this is connected with feedback, but there is no component present in the inverting terminal. So always output voltage is equivalent to input voltage. And there are two mode of operations for an operational amplifier. One is non-inverting mode and inverting mode. The non-inverting mode of operation, this is the configurations. There are two components are connected at inverting terminal to feedback, and input is given to non-inverting terminal. Then output is amplified but without shifting the phase. Whereas inverting terminal, the input is provided to the inverting terminal and non-inverting is connected to ground, and see the output, it is completely inverted with the gain factor RF by Rn. So there are two different mode of operational amplifier we have. And slew rate. And slew rate is the measurement of the speed, that is the maximum rate at which an op-amp can change the output without any distortions. So how fast it varies the output voltage with respect to time for every step input voltage. So this is measured in terms of volt per microsecond. For every microsecond, what is the changes in the output voltage, how fast it behaves, that is called a slew rate. And this is the applications of operational amplifier. Under linear, there are many things: scale changer, sign changer, adder, subtractor, instrumentation amplifier, integrated differentiated log, anti-log amplifiers. The non-linear characteristics, the op-amp can be used as linear as well as non-linear. And the non-linear we have comparators and zero crossing detectors, and there are schematic triggers, precision rectifiers, sample and hold circuit, clipper and clampers. And wave shaping, there are many things. We have sine wave generators, triangular and rectangular wave generators, astable multivibrators, monostable, bistable, multivibrators. So these are the three basic classifications on the performance of operational amplifier under linear, non-linear and wave shaping. And with this we will complete the first class, and in the next video we will discuss the characteristics of operational amplifier and also the internal diagrams. Thank you.